and very happy to be here sharing about this. So let's get started. Backdoors and breadcrumbs. We're going to be talking about, just as it was mentioned, persistence across the Microsoft 365 environment. So who am I? My name is Federico Cedolini. I'm a senior consultant in Toronto with Stroz Friedberg Digital Forensics and Incident Response. Several interests in cyber ranges from cloud forensics, M365 to security automation. I have several SAN certifications, and then I really enjoy hiking and sailing. And there is a picture of me there showing that I do in fact go outside, and please do not confuse me with Bigfoot if you see me out there. So what are we going to be talking about today? During your IR investigations, you're going to have different objectives. Here are four of the most common objectives that we will find across most of investigations. One of those is going to be determining the persistent mechanisms that the threat actor used to stay in your environment. One of the objectives, and usually one of the first objectives, is to try to figure out if the threat actor is actually outside of your environment, if they are not longer here accessing your data, using your resources. So this presentation is going to be focusing on this. We're going to be covering different techniques across the board. We're going to start with forwarding rules and inbox rules, jump layer to application passwords, diving deep into this not so well-known feature in Microsoft 365. Then we're going to talk about how threat actors can leverage self-service password resets, then jumping into OAuth applications, and finally into some more advanced techniques such as domain federation. And we will spend a few minutes at the end talking about how threat actors can go beyond your Microsoft 365 environment, beyond your Microsoft tenant, and leverage the identity of your users. So let's dive right into this. For your investigations, when you perform these investigations, and some of the things that you're going to see through these slides are going to be some events that get recorded in the unified audit log. If you want to hand through with this through your environment, you can use the PowerShell command to do it, or you can also use the Purview feature to do it. So let's dive right into these techniques. Let's start with a very, very common one, and this one is inbox rules. Inbox rules are designed to basically perform actions usually on new incoming emails. We generally see the threat actors leverage these on virtually most of BEC, business email compromises. These techniques basically allow them to we generally see them use this technique to basically obfuscate their activity by moving emails to folders that the user wouldn't generally be checking in, such as the RSS feeds folder or similar folders. But this feature can also be used to set up forwarding, meaning they can configure rules that allows any new incoming email to the compromised mailbox to be sent outside of your organization, and therefore allowing them to keep some persistent access to your organization data even after the account gets their password reset and multi-factor authentication reset. And the interesting thing about the inbox rules is that you can set it to forward to more than one external emails. Similar technique, along with inbox rules, there is the forwarding setting rules. Also placed directly within the mailbox is a feature that users and admins can leverage, allowing them to forward emails externally in an automated fashion, somewhere inside or outside of the organization, with the difference that the forwarding to be sent. So what can we do about this? Usually changes on inbox rules will trigger events. So what can organizations do to prevent or to remediate this type of persistent mechanisms? Using Defender XDR, automatic forwarding outside of your organization, a very good approach. Okay, let's keep going. So let's talk about a less well-known feature that is passwords. Add passwords is a feature designed to basically support legacy applications in Microsoft 365 that do not support the multi-factor authentication prompt. We fortunately do not see add passwords used in several organizations. During investigations, especially because it's disabled by default in most environments, and they require an admin to enable these features. Users can create weirdly up to 40 different application passwords. And something very interesting about applications passwords is that admins don't have such a good visibility into what users actually have applications passwords set up. So let's look at the case here that we investigated. Very interesting case. The threat actor compromised an account, in this case likely through phishing. Then they used that account to just browse around different emails, different files, and then they started to send phishing emails. That's when the client realized that an account was compromised. They reset the password, terminated the sessions. They removed any malicious MFA devices they could find. They disabled the account for a little bit. 1-2 days later, they re-enabled the account and they noticed that the threat actor was still able to send phishing emails from the account. They disabled the account one more time and then they engaged us. Something very interesting here is that they did remove all multi-factor authentication devices. They required the user to re-register any devices from their account, just wiping any MFA devices that were there. So what went wrong? Was the user phished again? Or did the threat actor manage to stay in a different way? In this case, we identified that the threat actor had set up application passwords. And remediating applications passwords is not part of many organizations' playbooks when remediating Microsoft 365, especially because admins do not have a good visibility into what users actually have a password set up. When you're hunting this across your environment, you can see events such as create application password for user that is recorded in the unified audio log. So as I mentioned, um, admins can see what MFA devices a user has registered, but they cannot see the application's password. However, admins can bulk delete these application's passwords, which could be something that you can add to your remediation playbooks if your organization uses passwords. So how to remediate this? You log into your Entra admin center, then you move user MFA feature. Then you select the user, and then through the settings, you can delete all the existing passwords generated by the users. This may generate some issues with some of the applications the user may use legitimately. So you can also have the user manually delete them from their profile. But from an admin's perspective, you can only delete them in bulk. So what can you do to prevent this type of persistent mechanism? Usually we recommend reviewing your environment and identifying if there is an actual need for application passwords for supporting those legacy applications. If there is not, we recommend removing, disabling the feature. Also encouraging users to move to applications that do support multi-factor authentication. So let's talk about the next persistent mechanism. And this persistent mechanism is more of a way to come back into the environment with something that they set up. Let's look at the very similar case that we investigated. Threat actor compromised the account, client identified, they reset the password, terminated the sessions. Then they disabled the account, re-enabled the account, and a little bit after that, the user noticed that they weren't able to log in anymore, getting a wrong password prompt. And then after that, they noticed that phishing emails started to go out from the account once again. So during the remediation, the client missed one step that was forcing the user to re-register their MFA devices. And because the client was leveraging the Microsoft feature SelfService password reset, the threat actor leveraged this feature to get back in. Usually when threat actors get access to an account, one of the first things that they will do is to add a new MFA devices, so they don't need to depend from phishing the user or compromising the user MFA device to keep logging in from different devices. So leveraging, what's this self-service password reset? As the name states, it's basically a feature that allows the users to reset their own password by verifying their identity using their MFA methods. If the admins do not reset the MFA methods, threat actors can also use these MFA methods to come back in to keep some persistence in the environment, locking out the user as well in the process. So what can we do in this scenario? Usually during remediation, you can configure, or before remediation, you can also configure your self-service password reset to require more of one MFA method to reset the user password. Usually we do not see threat actors registering more than one device. But if the environment is configured to only require one MFA method, such as the Authenticator app or an SMS, the threat actor will come back. So what are possible solutions? Well, you don't need to remediate MFA devices if the accounts don't have MFA, right? Believe me, that's not the right solution that we're aiming for. So what can you actually do? A very simple thing is simply to increase the number of MFA methods that are required for self-service password reset. I just pasted the link here. It's a quick check in your organization. It's just a toggle in which you verify what methods are actually allowed for password reset along to how many they are required. You can also set up some conditional access policies preventing the users from registering their own MFA methods. So very interesting technique for making sure that MFA devices are re-registered, and it's a step in your remediation playbooks. Let's jump to a little more advanced technique that we had seen threat actors use recently as well. ENTID applications are a key component of Microsoft 365. They basically allow your identity provider to connect to other applications and leverage some of the features of your Microsoft 365 environment through third-party applications. And they're key in most complex environments. As your organization grows, the need for more complex tools and applications will be needed, and you will be required to go outside of or connect your Microsoft 365 environment to these applications. So there are a few concepts we need to understand about ENTID applications. The first one is going to be app registration. This is the initial instance. It's the template of the application in your environment. It's applications that you are registering, that you're creating in your environment. This will generally contain things such as the branding, the API permissions, and the credentials. Another important concept that you're also going to see around is the enterprise applications itself. These are the instances of the applications in your environment. They actively use applications in your environment that have permissions to perform actions that they had been granted consent to perform different actions. Something interesting about this, they are also known as service principals. They are instantiated for those app registration, and they can also have credentials. So let's look at a quick example of an application. For this, we're going to be using an example of an application developed by Stroz Friedberg. You can find it on GitHub. It's the mail fetch app. That basically is a proof of concept on how applications can leverage the Microsoft Graph API to access emails, just as, for example, your backup applications may do. So right here on the screen, we have the app registration. It will contain some general information such as the application ID, the object ID in your environment, the name of the application. In the next slide, we see that we can assign credentials here. Some type of credentials that we can add are secrets that you can think of them as, such as an API key or a password. Or we can also include certificates as a way for the application to authenticate into our environment. And here's another example from the application registration in which we define what permissions this application has in our environment. For example, our mail fetch application needs permission to read the emails across all the mailboxes in our environment. Very common on backup applications. So now let's look at the enterprise applications. Let's look at the service principle. It is very similar to the app registration. We can see here a very similar menu on the left, and we can see the actually consented permissions in the environment. And the applications will be interacting through this service principle in your environment. So let's zoom in for 1 second in the menu on the left. What's missing from here? If you go through this and you compare this with the application registration, there is not an option to look for secrets or certificates that had been added to the service principle. However, I did mention at the beginning that service principals can have their own certificates and secrets to authenticate into your environment that can be different from the application registration. So this is a huge thing because this is one of the places that may, during your investigations, you may not realize that a threat actor, if you're only reviewing through the user interface, that a threat actor has set up a malicious secret to log in into your environment as the application. So let's look at an example. We're going to look at how threat actors may set up a password for a specific service principal, how we can find if there is a password for a specific service principal, and how we can remove it. In this case, we're going to be focusing on passwords, but similar commands do exist for certificates. This is something very common. We have seen more advanced threat actors do recently. The threat actors, the only thing that they need to do is after they authenticate with an account that has permissions, high-level permissions to add secrets or credentials to service principal, they simply need to specify the name of the secret as a reference. In this case, we're using my malicious secret, and then they just need to point it to the specific service principal. In this case, we're using our mail fetch application service principal ID. And just with one command, a new secret gets returned for the threat actor that they can now leverage to impersonate the application and just use the same permissions that this application has. As I mentioned, backup applications are a very common one because allow them to, without needing the credentials for the users, look at their mailbox, look at their OneDrives, for example. How can we find these credentials? It's a very simple command in PowerShell, mg service principal, and then we specify the specific service principal. We're looking for, in this case, because it's a password, for password credentials. We can see here the output is just the one that we set up on the previous screen and when it was added, when it can, for how long it is actually valid. And how do we want to remove it? It's just as easy as pointing to the service principal and the key ID that we just got from the previous slide. So you are hunting, you want to detect this type of persistent mechanisms, you are going to be looking for these events. Events related to update application, updating the service principal. These are the operations that you're going to be looking in your unified audit log. Additionally, to add service principal credentials or update application, certificates and secrets management. They do correlate to the specific, either the application registration or to the actual service principal in your environment. So you can set up, this is not something that happens super often. So this is something that you can set up alerts for wherever you're ingesting your logs. So preventions, make sure that you limit the number of users with high privilege that can actually register new secrets to applications. Make sure that you implement conditional access policies to limit where applications can sign in from. Your service principals will generally be logging in an automated fashion, generally from the same location. So if you have the correct license in Microsoft 365, you can set up some geofencing around those service principals. And your users should not be allowed to just add any applications to your Microsoft 365 environment, because we see threat actors that they love to do that, especially for exfiltrating data. So one of the options is to required admin consent to add new applications into your environment. And it's a very simple thing that you can change in the ENTID portal under user settings. So let's talk about one of our last techniques of the day, and this is going to be domain federations. Some of you may be having some flashbacks from APT 29 a few years ago and the SolarWinds incident. So let's dive into this very interesting technique. Domain federation basically allows third-party identity providers, such as ADFS, to authenticate for your users. This can be third-party domains, or they can also be cloud only. Something that we need to understand in domain federation is the federated realm object. This object configured in your ENTID will contain things such as your login and metadata URL, and it will contain the certificates that is used by that identity provider to issue tokens. Federated domains can issue SAML tokens, login tokens to authenticate to any users in your tenant, regardless or not the user belongs to the federated domain, which is super interesting. So how do threat actors are leveraging this? They compromise a global admin account or a high privilege account. Another example that is able to either add a new domain to your environment or to modify an existing domain is the hybrid identity administrator or the global admin. There are a few other permissions or roles that will allow you to do parts of the process, such as security administrator, for example, but doesn't have as much power as these two roles. With these two roles, the threat actors may add a new federated domain, and along with it, a new certificate that they created, or they can change an existing domain that you already have in your organization and add a new certificate. With that certificate, they can basically issue new tokens to impersonate any users across your environment. And with this token, they are able to bypass any password or MFA requirements and just basically access as the users to the resources that are allocated to them. So this is a very advanced technique. However, if you have detections around it, it's very easy to detect because your domains in your organizations are not changing often. You should be on the lookout for set domain authentication and set federation settings on domain, which will be basically hinting that a new certificate may have been added to the newly added domain or to an existing domain. So let's talk about some very interesting, I call it persistence in this case, but it's a recent trend in which we have seen threat actors leveraging the identity of the users that they compromise to create account on third-party sites. And very common third-party sites are Dropbox or FileShare, in which they can generally use for spreading more phishing. They may use this account to create basically a third-party account, a third-party login into these platforms, and then leverage the identity trust that other organization has with your organization just by doing their general business, just by being a well-known brand. They can leverage this identity to keep on phishing even after you remove them from your environment, just impersonating your user through these third-party services. Very unfortunate, there is not that much that you can do in terms of prevention. During investigations, however, you should pay special attention not only to the emails that are being sent out by the threat actor from the compromised account, but also to the emails that are being received to the account to identify potentially any new accounts that they may have created using the compromised email and verified with the email as well. Once you discover that threat actor may have created an account in a third-party site, you should work with the user or directly with the account to reset the password on this third-party platform, preserving any available logs, and probably taking appropriate actions such as deleting potentially phishing documents after they had been collected. So I know I covered a lot of things. Thank you for sticking with me through those technical difficulties, but now I have some time for some questions, and I also want to share some special thank you to the Stroz Friedberg team. If you're looking to get inspired, want to get more information about some of the blog posts that we write, you have here the URL for that.